we're talking about communication cables, we refer to them by their category or cat number. But what is the difference between Cat 5, Cat 6 and so on? In the dim and distant past, Cat 1 and Cat 2 cables became the standard for voice communications. They were twisted pair cables, and whilst they could support very low rate data transfer, they were not designed for this purpose. In 1991, Cat 3 cable was ratified by the Telecommunications Industry Association, the TIA, as the first official standard for data transfer, supporting speeds of up to 10 megabits per second with a maximum frequency of 16 megahertz. Cat 3 was replaced by the brief appearance of Cat 4, which was then superseded by Cat 5 cable. Cat 5 utilizes 4 pairs of twisted cores capable of a frequency of 100 MHz and a maximum transmission speed of 100 megabits per second. Cat 5 laid the foundation for Ethernet as we recognize it today. These days, it's generally regarded as too slow for most data transfer applications, but for low bandwidth systems such as building automation, it can still be used effectively. In 2001, the Cat 5e standard was ratified by the TIA, with the E standing for enhanced. Cat 5e still has a frequency of 100 MHz, but can support transmission speeds of up to 1 gigabit per second, or faster when used over shorter distances. The following year, Cat 6 was ratified, offering similar performance to Cat 5e over a 100-meter Ethernet segment. The high frequency of 250 MHz meant that under some circumstances, it could support speeds up to 10 gigabits per second. A further variant of Cat 6 is available, known as Cat 6a. The A stands for augmented, and this cable category fully supports 10 gigabits per second transmission speeds at a frequency of 500 MHz. Cat 7 and Cat 7a cables are also available, both supporting similar transmission speeds to Cat 6a but at higher frequencies, 600 MHz and 1 GHz respectively. The latest standard is now Cat 8, which has an astonishing transmission speed of up to 40 gigabits per second and an upper frequency of 2 GHz. It is worth noting that fast data transmission systems will be more likely to use fiber optic rather than copper cabling. For this reason, the switch from Cat 6 and Cat 6a to the newer standards has been slow, as the Cat 6 standard already supports very high transmission speeds. For building automation applications, we often find that our hardware operates using 100 base TX, which can be supported on the old Cat 5 standard. However, it is always sensible to future-proof systems where possible, and so Cat 6 is often specified or adopted as the minimum standard for building automation communications systems. Cables are backwardly compatible. For example, an older 10 base T system can be connected using Cat 8 cable, but its maximum speed will still be 10 megabits per second. It is therefore beneficial to use a more modern standard when installing cables, as new hardware, operating at higher speeds, can be supported without the need for costly infrastructure upgrades.